Hello, I am Apuro SV from Sri Sairam Ishwari College. Today I am presenting my topic that is classification of COVID-19 samples using neural network and rapid miner. During the COVID-19 pandemic, biological samples were collected from different parts of the human body, such as saliva, oronasopharynx swabs, lung samples, and fecal samples. These samples are diverse in nature, and because of this diversity, it becomes challenging for traditional machine learning models to classify them accurately. To address this, we used a deep neural network model implemented using H2O AI and RapidMiner Studio. Before training the model, we performed several pre-processing steps. The metadata was cleaned and standardized. Categorical features were encoded numerically. Missing and redundant values were removed. This ensured that the dataset was reliable and consistent for model training. The deep neural network consisted of 11 input features, two hidden layers, each containing 50 neurons, a 10-class Softmax output layer. We used the rectifier activation function and cross entropy as the loss function. To reduce overfitting, L-known regularization was also applied. The model was trained on approximately 1 lakh samples, running for 10 training epochs. As a result, the model achieved a top one classification accuracy of 90.7%. The R square value was 0.724, which means the model was able to explain around 72% of the variation in the data. We also obtained a log loss of 0.249, indicating high confidence in the predictions. In metrics, we evaluate how well our model performed. Our top one accuracy is about 90.7%, meaning the model correctly predicts the result most of the time. The R square of 0.724 shows that our model explains over 72% of the data variation, which is quite good. We also have a low log loss value of 0.249, indicating the model makes confident predictions. The top two accuracy is 99.9%, which means if the first prediction is off, the correct answer is almost always in the second choice. On the right side, we describe the model setup. We use the two-layer neural network with rectifier activation attained for 10 epochs using cross entropy loss. It's a small and efficient model, only about 48 KB, making it easy to deploy. The tech stack for developing this model, we worked mainly with H2O AI and RapidMiner along with Python. These tools were chosen because they make it easier to build, train, and evaluate deep learning models visually and programmatically. The model we used is a deep learning multinomial classification model. This simply means the model is capable of classifying the input into multiple categories, which in our case are the different COVID-19 sample types. To support this, we made use of a few important Python libraries. H2O for building and training the neural network, NumPy for numerical calculations, Pandas for handling and organizing the metadata, and Matplotlib for visualizing results like training performance graphs. Our data set was taken from Kaggle, specifically the COVID-19 Metadata Dataset. This dataset contains sample-related metadata such as specimen location and handling details, which allowed us to train the classifier effectively. For the development environment, we used RapidMiner Studio integrated with the H2O extension, and we also made use of H2O Flow for model monitoring and tuning. This environment provided both a visual workflow, canvas, and backend computation, making the training process more intuitive and transparent. So overall, this tech stack allowed us to combine data pre-processing, model building, evaluation, and visualization in a streamlined workflow, making the project both efficient and scalable. This slide represents the key performance of our deep learning model. As training progressed from epoch 1 to epoch 10, log loss and RMSE steadily decreased. The R square score increased from around 0.578 to 0.724. and the classification error reduced from 14.2% to 9.3%. This confirms consistent learning and performance improvement. In the class-wise results, saliva and oronasopharynx samples were classified with good accuracy, while overlapping sample types showed higher error. Lung and swab classes had very few samples, so the model could not generalize effectively. This highlights the need for more balanced data in those categories. Overall, deep learning was able to capture complex relationships effectively, showing major improvement over traditional classifiers. The model's overall accuracy improved from 89% to 90.7%, and the R-square score improved from 0.659 to 0.724, demonstrating strong and reliable performance. This slide shows the main steps of our project workflow in RapidMiner. The first image displays the overall process flow, including data input, pre-processing, deep learning model training, and evaluation. The second image shows the deep learning model configuration and training details in the H2O extension environment. The third image presents the model's prediction results and performance visualization, which helps us to analyze how the model behaved across different samples. Finally, the last image shows additional evaluation charts used to interpret model accuracy and distribution. These images together demonstrate the end-to-end workflow from data preparation to training and final performance analysis. Thank you.